Hello. For this video series, we're going to look at several 3D vector algebra problems from the IB Cambridge textbook. And I'll comment a couple things. When working with 3D vectors, it's really valuable during the homework phase that you access, I'm using GeoGebra Classic here, but any sort of online 3D graphing software so that you can really get a sense of what's happening. It's possible to get through the vectors program and just memorize everything you need, but it's going to be really difficult when you get into some of the high-level IB kind of thinking that's required. So the value in a figure like this one is I could understand the points A, B, and C, and then I could understand that the points, these dots, are arrived at through vectors shooting from the origin. Then it makes it easier for me to see, perception-wise, where the parallelogram needs to be put. Just in case you didn't have a chance to read the problem, three points are arrived at by vectors. There's a fourth point D that creates a parallelogram. Where's that fourth point? So using just the geometry that I have here, we can perceive two different ways of getting to that point D. One way would be to match the vector BA with the vector CD so that you have two opposite parallel sides of the same length. Conversely, we could also take the vector BC and project it from A to D. And so that's the plan, and the beauty of this question is that I could use one approach to get my value for D and use the second approach to make sure that D is in the right place. So the first thing I need to do is express the vector BA as a position vector from the origin. Basically, what it's going to do from the origin is it'll tell me exactly what the three components are that comprise this direction and magnitude. So to do that, essentially, I have to take this vector BA and walk it home. That is to say, I need to slide it down this green vector so that the red vector starts from the origin and projects through space this way. The way that the algorithm works is you simply subtract. And in this case, we're going to subtract 2, we're going to subtract 1, and then we're going to subtract 5 from the vector A so that we can actually, like I said, position down by the origin. So we're going to take the vector A, subtract B from it, and that produces the new vector, -3, -2, 2. And if you look, you can see that if we go back 3, back 2, and up 2, that we do in fact have a vector in the direction of BA, but now centered on the origin. Now that we have this vector, all we have to do is slide it up the vector C. In other words, if we add the vector C to this position vector from the origin, it would become the vector CD. And making the observation that OC plus CD equals OD, here's OC plus CD would equal OD. That means I'll have the vector that will shoot me straight to the point D. And so in so doing, I add the position vector AB to the vector C, and I get 0, 1, 0, -1, 6. So I didn't plot that out here, but if we were to go 0 and then forward 1, or actually this way 1, I don't remember. Oh yeah, -1, back 1 this way, and then up 6, that takes us straight to D. And just to verify this, now that we get the sense of the calculations that are required, we can play the exact same game with vector BD. So we're going to send it back to the origin just like I did before. And then I'm going to add along the vector A so that we can go up this way and over that way to get the vector OD. And it indeed gives me the same values. The important thing to do here is make sure that I've answered the question, and it said find the position vector of point D. So it's not asking for the point, which the point would be 0, -1, 6 written as 0, -1, 6. We're not looking for the point D, we're looking for the position vector that gets you to the point D. And I believe we've achieved that goal and supported it. So that ends part 1 of this video series. In the next series, we're going to look at a very similarly natured problem, but this time it involves adding two vectors where there's a scalar to one of those vectors and having that new sum be parallel to some random given vector position. Stay tuned.